Okay, so today we're going to learn about integration for trigonometry, but before that, let's remind ourselves our old basics. So if I give you sine 3x and I want you to differentiate them, what do you get? Cos 3x times 3, okay? And then you differentiate inside, times 3, of course, you're going to put in front. Now, what about if I give you cos pi minus 2x? Differentiate. Differentiate cos first. Negative sign. Pi minus 2x, copy them back. Then differentiate inside here, what do you get? Negative 2. Oopsie. Out of bound. Yeah, negative become positive. Just some basics. Now what about if I say to you differentiate tangent 2x over 5? Sec squared. Sec squared what? 2x over 5. You copy them first and then 2 over 5. Okay? As simple as that. So now let's try to integrate. Integrate sine 3x. Integrate sine, what you get? Differentiate what you got sine. Differentiate cos give you sine, but it give you negative sine. Negative cos. Don't forget your negative. Be careful on that one. Cos 3x. And then you need to differentiate inside here. But where should you put? Down. Integrate, you always put them down. Are you okay? Yes. Don't miss them. Now what about this? Integrate cos, or basically asking differentiate what you get cos. Sine pi negative 2x. Differentiate here over negative 2. Remember, integration we always put down. Plus C. Yes. Always transfer down. Now what about this? Integrate sec squared. Ask your question back. Differentiate what I get sec squared. Tangent. Okay. Are you happy with that? Are you happy with that? Differentiate the bracket over 2x over 5, which also I can write down as 5/2. Aha. When it comes to something over fractions, everybody gone silent. The easy one, people always speak first. Okay, so moral of the story is be careful. Sometimes you need to know if it's squared, you get what. Alright? I can go on and further, things are more complicated than that. Okay, I'm quite sure by now you'll be bombarded with a lot of formulas. This formula, this formula, this formula. Seriously, a lot of formula. This formula, this formula, this formula, and so on. My advice will be this: don't use any of them. Use the one that you will get in exams. Because if you use too many formulas that suddenly doesn't come out in exams, you're going to get panic. In exams, you will only be given this formula. This one is the same as your trigo on your last class, on your last semester. I hope you haven't thrown them away, or at least don't burn them down. You're still going to use them, and of course, for differentiation and integration formula, this is the only one that you will be given. These are the only one that you will be given. For trigonometry specifically, it's only this. So I highly recommend, if you're going to study this topic, or at least you're going to memorize the trigonometry, based on here. That's why whenever I say to you just now, integrate this, you got what? I always ask you, differentiate that, give you what? How do you get that? You differentiate that, you get from what? Like set squared just now, my question was, differentiate what? You get set squared. And suddenly all of you can answer. Alright? My recommendation would be that memorize from this direction. Okay? Differentiate to integrate rather than integrate to differentiate. But that's just my personal opinion. How are you going to study this topic? From which formula and whatever? It's only from here. If you feel unsatisfied, sir, I want more than this, sir, then write it down somewhere over here. So maybe and hopefully when you go to exam, you will have that picture memory over there. Alright? Something else that you're going to need it desperately is factor formulae. You're only given part of it over here. Can I borrow a pen? Okay, alright, Assalamualaikum. So there's a bit of a correction. Okay, and how to change this one to the factor formulae to the product of. You'll be needing to firstly copy them first. Sine, nothing much, plus sine. Okay, maybe I need to space a bit. Sine. Just copy them first. Equals, 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 equals. 2 sine cos, 2 cos sine, 2 cos cos, and 2 sine sine. Okay, one thing that I forgot last time, there's a negative for down here. So do not forget this negative. Okay, don't be like me. And then from here, if you look here, this A, B. Now over here, this one becomes AB. AB, 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 AB. Or you might want to say all A and all B. Now this one over here, if you look on the side, is A plus B. But this one here over here, it just becomes A plus B. I mean, this one got over 2, this one have no over 2. This one here over here, A minus B over 2. This one over here, there's no over 2. Right, so A plus B, A minus B, A plus B, A minus B, A plus B, A minus B, A plus B, A minus B. Okay, so this is how you get the factor formulae as quickly as possible from your formula sheet that will be given in exams. I hope there will be practical advice from you, for you. Okay, thank you. Let me zoom out for a moment. You might need this one, but this one is basically the same as this one, so it's pretty much optional. And the formula that you desperately need is these two. For integration, you need it badly. I explain to you soon. Okay, I'm giving you a practical tips for exams here. Thank you very much. Oh, the hero of the pen of the day. And the guy sits beside him. Okay, there's a few rules for, there's a few different see. Okay. For differentiation, if I give you something like this, sine squared x, can I differentiate it? You get yourself, firstly differentiate the power, 2 sine x, and then differentiate the sine, get cos, and then finally you differentiate the one in the middle, the one in the bracket, okay? As simple for that as that for differentiation. And if I give you something like this, sine x, cos x, can you differentiate it? Yes, you're right, I can do product rule, sir. UV, so you're going to get yourself U prime V plus UV prime or something similar to that, which we are not going to write it down. You get the idea. But these two rules doesn't apply for integration. Okay? So I'm going to summarize a bit. This one here is okay for you to have trigo power. It's okay for differentiation. It's okay for you to have trigo 1 and trigo 2 multiply. Trigo 1 and trigo 2. If they are multiplication, it's a times. For differentiation, it's okay. But these two rules doesn't apply for integration. Alright? If you want to integrate a formula, integrate a trigonometry, it needs to be single power, only one. Only power 1, and no times with something else. Only one power and not multiply with other trigo. These are the bread and butter for this topic, the main part for this topic. So you can say integration of trigo is pretty much selfish. Okay, so let's go through some of the examples. What I've given you just now is that the simple case. Can I move on? Okay. If I give you something like this, integrate of sine squared, what can we see here? What rules does it violate? The power. This one got power 2. Maybe I write down better for YouTube. Yeah, you know, people all over the world. Okay, so right now the power is 2. It need to be power 1. How do we make it into power 1? Boom! I mean up here. It looks cool in the head, but you know. You're going to use this one. So sine squared, you're going to use this power. What power is this? Power 1. Alright? So we got ourselves. Okay, if this one is sine A, I got cos 2A. Right now I got sine 2x. So I got cos what? Cos 4x. 2 times 2x, I got cos 4x. So 1 minus cos 4x over 2 dx. Are you okay with that? Well, it's quite horrible, sir. Yeah, good idea. And it depends from here. I personally, I will write down this straight away. It depends on your choice, on your preferences. I will personally go here. Because over 2, 2 is constant, so just take it out straight away. Okay, so from here then only you can continue. Integrate 1, what do you get? As easy as that. Integrate cos or differentiate what? You get cos. A negative sign. Do I smell danger? Remember, you need to differentiate inside here. Oh, sorry. Remember, you need to differentiate the 4x. Are you okay? Oh. They remember. Okay, here, full pic if you want to take a picture. Are you okay? Understand? What rules does it violate just now? Power. It need to be only power 1. Very good. Can we continue? Okay, let's try this one. Since this one is a Trigo 1 times with Trigo 2, so you are not allowed to use integration straight away. So you need to use the formula, which is this one. Since this is a sine times sine, so we're going to use this one. Okay. Yeah, there's a negative at the end of the formula. I miss it at the first part. Be careful, don't be like me. So we got ourselves, according to the formula, is cos minus cos. And it's a plus b, so a plus b becomes 5x here. And then for this one here, a minus b, so 3 minus 2x, 3x minus 2x becomes x. Since this is a negative 2, which is not included in this original formula, so we got ourselves 1 over 2 negative. And we integrate them as usual, integrate for cos, differentiate sine, get cos. So sine fx over 5, I got confused a bit, minus sine x. Oopsie, we have integrate, so there's no more integration sign. And don't forget to put the plus c. And then there's of course this negative 1 over 2. And yeah, I think you can end it this way, just rewriting. You can choose to, I think this one is okay, but of course you can multiply them. Alternative answers will be sine x. Normally you don't want to have too many negative. I guess I prefer this one instead. Okay, thank you. Okay viewers, you can please try this one first. My class has done it. I'm going to straight forward with the answer. Okay, so the answer will be, okay, sorry. Okay, the answer will be, you're going to get something like this, am I right? Sine 6x plus sine 2x. Oopsie, too many brackets. Do you got the same things? And then integrate sine or differentiate what? You got sine, positive sine. Negative cos 6x over 6. This one the same thing. Cos 2x over 2. 1/2 plus c. I don't really like these answers. The negative you can factorize further. This 6 and 2 is pretty much optional because it's only constant. Or if you want to factorize 2. Okay, but this one is okay. Both of them are okay. Why I prefer this one? Because there's too many negative. Just take it out. The 6 and 2 is optional. You don't have to take it out because you don't have to factorize 6 and 2 because it's just a constant. Alright, done. Okay, for this kind of case where you got yourself I'll show you the question. Okay, for this case you see you have two types of trigo. One is sine, one is cos, one is sine, one is cos, but the angle are the same. Same angle, different trigo. You may use this formula instead. You see? Let's say you don't remember these things, sir, and I just want to stick with my old one, sine and cos, this one here, or cos and sine, which is kind of the same thing, then it's also okay. But of course, if you are smarter, then you see yourself, hey, I remember this is a double angle, this is a double angle formula, then you might want to use this one instead. Right? Remember there's a 2 over here, so this one 2, you can use it straight away. But for the second one, there's no 2, right? So you need to transfer your 2 to the other side. Okay, I will show them briefly. For the first one here, you can just directly get yourself into by using the formula. There's 2. There's 2 here, okay? So the angle you need to times 2. The angle here to x becomes 4. So integrate that, what do you get? Cos 4x over 4 negative plus c. Okay? What about this one here? Sine, cos, so different trigo, same angle. I get myself sine. And then remember the angle you need to times 2. So 6x becomes 12x. But this one doesn't have 2 in front. You need to have 2. So what happened? 1/2. Okay, going to give you sort of the same thing. Cos 12x over 12, 1/2. I think there's a minus there. Yes, there's a minus. Sorry. Mistakes 1, shame on me. Mistakes 1, shame on you. Mistakes twice, shame on me. And multiple mistakes I'll be making in the future. Cos 12x 24 plus C. Oopsie. Are you okay? Things looks good. So now for some extra exercise question. Are you okay? Can you move on? Now, what about this? What do you think? Integrate sectant, what do you get? That should mean something already. The moment I say it out loud, you should understand it by now. Integrate sectant. Differentiate what gives you sectant? Boom. Setan. So you should get sec x over 3. Now what happened? Is that all? Yes, it's no, obviously. Differentiate x over 3, what do you get? Differentiate x over 3. 1 over 3, where should I put that 1 over 3? Down. Out here is negative 3. Negative 3 is a constant. You can sort of bring it out just now. Not going to affect the equation. So how now? Is it okay for you to leave your answer that way? Some people said no because you need plus C, sir. Very good. But can I leave my answer in this way? Still no, I need to solve this one. I cannot have fraction over down there. So what do I get? Negative 9. You okay? Can we move on? Okay, this is a bit annoying. And I try my best not to make the handwriting worse. What do you think of this? Okay, let's make your life a bit simpler. What does pi over 2 means? It's a constant, so you can take it out. Now what about the cosec and cot? Should I split it up? Or should I do something with it? What should I do with the cosec and cot? Should we use this as a factor formula? Go back to the basics. Your first question will be, is there anything that I differentiate, I get cosec cot? Yeah, it's over there. But that's a negative cosec cot. So that means you need to put your negative this side. Alright? So, negative cosec, I don't need this one anymore. 2x minus alpha. Differentiate 2x minus alpha over 2 plus c. Said how should I leave my answer? Well, can be more negative pi over 4 cosec 2x minus alpha plus c. Please don't kill anyone in my class. YouTube ban live killing. I don't want to be Logan Paul here. For those understand. Okay, I'm gonna leave the rest with you. I'm gonna test you one more. How do you integrate this one? You cannot. Why cannot? The power. Something wrong with the power, sir. So what should you do if there's something wrong with the power? Find the formula. Which formula? I like that question. Yep, this one here. Okay, can you try it by yourself right now? Try it out. Can you see? This is a formula. And there's a question. Okay, you should be able to get there. 1/2 1 minus cos x and integrate this. What do you get? X minus sine x. Okay. We have a bit of time, but oh well. I'll choose this one for you. What about this one? Sorry, pi. This one is pi. This one is 3. Handwriting. What do you think? What do you think? How should we start? Split. Okay, split. So integrate to x, simple as that. Now what about cosec? What's wrong with the power? Power 2, okay, so what should I do with the power 2? Make it into power 1. Okay. How are you going to make it into power 1? That's a formula, but this thing is only for sine and cos. This is cosec. Yeah, speech. Oh, I like that answer. Yeah, do we have anything that we differentiate with cosec squared? Oh yeah. So you got cot. Okay, you differentiate. You got cos x squared. Okay, so we use this one straight away. Remember there's a negative here. So we got ourselves negative cot. I'm going by gut instinct here. And 3x minus 4 differentiate inside over 3 plus c. I think that should be enough for today. Pi over 4, yes? Should I have pi over 4 here? Yeah. I'm tired. Thank you. Well, since you've been so kind, so I add one more question for you. I'm just writing it down so you can try it out later. Okay, viewers, you may want to try. Class, here's the answer. Write it down somewhere else. Okay, viewers, have a look, but give it a try first. Oh yeah, what's the problem with this question? Maybe I should ask that one. You see that trigo are the trigo times the same is nothing to do with it. It's a times trigo. So which formula should you use? This one here. Okay, so times you need to make them single. Alright, that's all for today for integration trigo. Hopefully this helps you guys. Thank you for listening. Bye.